Good morning, everyone, again. So I'm Giulia Malinverno. I'm a senior application engineer at Ansys, where together with Samuel Lopez, we are the main maintainers and developers of PyAEDT and all related initiatives. So this is the agenda that I would like to cover for this 15 minutes. It seems very short, but you will see that we will cover many concepts. And first of all, I'll introduce you to PyAEDT and all the reasons behind its creation. And we will go a little bit more in detail, trying to understand what PyAEDT is and where it is. So we will start with aedt scripting limitation. So as most of you already know, scripting is already available in aedt, but it comes with a lot of limitation, and this is the main reason that brought us to create a new set of technologies to Pythonically interact with Ansys Electronic Desktop. So Ansys Electronic Desktop is an integrated desktop environment where Ansys Electronics products can come together, so the user can access all the physics such as HFSS, Maxwell, Q2D, Q3D, ISPAC, and so on. And aedt integrates a complete application programming interface, so the so-called API, which enables most of the interface commands. In fact, there's the possibility, as you can see here in the screenshot on the right, to run and record a script that can be recorded either in IronPython or as a VBS script. But aedt scripting has some limitations, as already said. So first is the application that is executing the script. And we will see in the next slide that with PyAEDT, this relation can be reversed. Second is IronPython, so the language in itself. As we will see later, PyAEDT is implemented in CPython, and this allows to access the full capabilities of Python within aedt, within Ansys Electronic Desktop. And most importantly, it allows to build advanced workflow by leveraging existing Python libraries, so the third-party libraries such as NumPy, Panda, Matplotlib, and many others, and allows a dynamic interaction with the Ansys Electronic Desktop. The fact that it's implemented in CPython, it brings us the debugging and development much more easier and improved, because we can leverage popular IDE, so the so-called integrated development environment like PyCharm, Spider, Visual Studio, and many others. And then finally, we have a more efficient code generation. So PyAEDT brings a simplified scripting syntax. Generally speaking, scripting in aedt is powerful, but the code recorded is very dirty, the code reusability is very low, and API commands are not homogeneous across the solutions, which makes the scripting more complicated. And with PyAEDT, we were able to overcome all these limitations because it's now the Python program, so the PyAEDT program or the script, that has now become the main application, and aedt has become the application used by the script. So now we can start the real discussion about PyAEDT. I really like these two pictures, especially the one on the right. So, because to properly understand what it is PyAEDT, we can think of PyAEDT as it is for all the other Python libraries included in PyAnsys. We can think of it as an additional layer built on top of the existing API that extends and consolidates its functionalities. So if we account for the right picture, we can think of the blue circle as the physics. So for example, Maxwell. The yellow one is the Ansys solution, so Electronic Desktop, Ansys Electronic Desktop, aedt. And the light gray is the native IronPython API, and the dark gray is PyAEDT, so the Python environment that functions as a wrapper on top of the IronPython API. So based on that, we can think of PyAEDT as the connector between scripts and aedt. It allows to use CPython, so the global programming standard, and provide a simplified syntax. It's very important to say that PyAEDT is not intended as a replacement of the existing native API, but as you can see in the previous screenshot, on the previous slide, it's intended to consolidate and extend its functionalities as an additional layer. So here I wanted to put our roadmap because this has been our journey so far. So we started a couple of years ago and we've now reached version 0.11 that was released actually yesterday, where we achieved another great milestone where we separated the examples in a different repository and we gave them a new format to be compatible with Jupytex in order to be rendered and run in Jupyter Lab. And and we set ourselves the goal of releasing version 1 of PyAEDT by the end of the year, on the first months of the next year, where with version 1 we will finally reach a stable and definitive release. Here I put a couple of slides about the repository just to give you an overview and some statistics. So again, it supports all AEDT application, as I said, HFSS, Maxwell, Q2D, Q3D, and so on. Another very important thing is that it integrates PyDB with HFSS 3D layout. For those of you who don't know, PyDB is the Python client library for processing complex and large layout designs in Ansys electronic database, the so-called EDB format. It's directly accessible in aedt through the automation tab. In fact, you can see in the top right corner the so-called ribbon bar that is available in Ansys electronic desktop after you carry out the installation. In fact, here you can see that through the PyAEDT console, you can directly access PyAEDT within the Ansys electronic desktop environment. It supports toolkits. Here a brief explanation about toolkits. We can think of toolkits as complex workflows with the UI that you can directly install through the extension manager. Again, you can see on the top right corner. Through the extension manager, we will see later, we can install this complex workflow that have a UI. Right now, we have two available toolkits, one for for high frequency application to design antenna, and one for low frequency application to segment and skew electric motors. There's the possibility to access advanced post-processing with the third-party libraries such as PyVista, NumPy, Matplotlib, and we also have the automatic PDF report generation. Again, some statistics about code coverage, tests, and compatibility, just to grasp the idea on how big this project, this repository is. And finally, where is PyAEDT? So here again, some of my colleagues already said that it's important to say that PyAEDT, as it is for all the other PyAnsys libraries, it's not an Ansys product. It's for the community, and everyone could add or review the functions. In fact, it's public and open source. It's accessible in GitHub at the link that I provided here in this slide. Anyone can contribute through issues, pull requests for bug fixing or enhancement requests. So feel free to contribute both in PyAEDT repository and the newly created PyAEDT examples, because your help is more than welcome. We also have a dedicated documentation page that helps getting started with the installation and setup, as well as API reference and examples. Very quickly about the installation, as I mentioned before, Here is a guide on how to install PyAEDT and the ribbon bar where you can access PyAEDT through aedt. So in the documentation page, the user can download a Python installer, which is basically a Python script, and run it within aedt with the run script option available in the automation tab. And this will install a PyAEDT virtual environment in the app data folder and the ribbon bar in aedt. The one highlighted in red with the 3 number. From version 09, the script needs to be run and installed only once, and toolkits and extensions will be available and reused across all the aedt versions you have installed in your local machine. aedt versions that are greater than 23.2. Of course, if they share the same personal library. Here another way to install PyAEDT, because it can happen that sometimes customers, especially the ones in the aerospace sector, have limited access to internet or no access at all. In this case, it's possible to install PyAEDT and the ribbon bar with the same installer, and providing a path to a wheelhouse file that is downloadable from PyAEDT releases page. The Python installer can be used to install PyAEDT offline by simply providing in the script arguments, as you see on the screenshot on the right, the wheelhouse name. And from the releases page in the PyAEDT GitHub page, you can download the wheelhouse depending on the operating system and the Python version. And as you can see in the names, you see the names in the screenshot on the left. So once the installation is done, you should be able to see in aedt automation tab a new ribbon with some buttons, one of which is the extension manager. I already showed you before. So this is a very important tool for customers because as you see here, you can do 3 main things with the extension manager. So first, you can install custom extensions. And with these, you can pass a script, a path to the script that you want to install, and this will install a button. Through this button, you can directly access within aedt your own workflow. So as you can see, it's very straightforward. With one click, you can directly access your workflow within aedt. The second option is install pre-installed extensions. So we already created some predefined extensions, such as, for example, the advanced field calculator. For this, I suggest you to visit the user guide, or we can see in another session to go more in details. Or third option, install the toolkits, the ones I mentioned before, the complex workflow that are open source and with a dedicated UI. But I won't go too much in details for now. So just to conclude what we have seen so far, PyAEDT allows access to CPython, as it is for all the other PyAnsys libraries. Python allows easier code development, maintenance, and scalability, and above all, allows automation of tedious tasks and for pre- and post-processing. It simplifies the development of vertical application and allows access to internal or external advanced optimization tools. So this is PyAEDT, and that's it on my side.